Way through this.
You prepared to argue with me.
I love arguing. Today is 4-3. This is just operations in base. Again, 4th grade mathematics. I'm going to teach you how to add, subtract, multiply, and divide. But since we're not going to be working with our numeral system, it's going to be a little strange, and you just have to get used to it. We've already laid the groundwork for it by converting numbers back and forth between the two bases. Did I spell operations right? I always feel like there should be two P's. I don't want two P's, but like my name K-I-L-L. I love the double letters. Those are the only words I could spell right in school. Book. B-O-O-K. Alright, so if we're going to do operations in base, let's start with addition. And I'm going to build us up from simplistic into a little bit more complex type of systems, but nothing ever changes. And what's going to happen here is we're going to do like two different things. Number one, we're going to add the numbers in our base. Number two, we're going to have to take that answer and convert it into their base. So we're going to be doing a bunch of little things, and that's where people get confused. For instance, if I take 2 base 5 and I add 2 base 5 to it, what's the answer?
4 base 5?
4 base 5, because 2 plus 2 is equal to 4, and there is a symbol of 4 in base 5.
So, okay.
Okay, you just walked in the door. You don't get to ask questions. I'm joking, Jay. Go ahead.
Oh. So, if it said...
I'll get there. Trust me, I'll get there.
Don't come in.
What if I wrote this?
So you're only adding the two big numbers and not the
Oh,
base?
yeah, the base is just saying what base you're in. It's not a value. It's just saying what base you're in.
So it's going to be...
Oh, hold on. If I have 2 base 5 plus 3 base 5, now I have a problem. Because 2 base 5 plus 3 base 5 is 5, but I don't have a symbol for 5, so I have to do a conversion.
Oh.
How many 5s are in 5?
1.
With a remainder of 0.
0.
So this number 10 base 5 is the same thing as 5.
Wait, whoa.
Well, let's go back to our numbers then. 3 plus 7 is equal to, is there a symbol for 10 in base 10? No. So why do I write 10? Well, I write 10 because in base 10, how many 10s are in 10? 1. How many are left for the 1s? 0.
Wait. What is the 3 and 7?
I just made it up. I'm making up numbers.
3 plus 7 is 10.
Yeah.
3 plus 7 is
But
10.
it's base 1 and 0. I don't
Where'd it
know.
come from?
I made it up. Where'd the 2 and the 3 come from? I made them up. I'm just making them up.
Okay. Then 2 plus 3.
Okay, so 2 plus 5 is 5. And then
2 plus 3 is
2 plus 3
5.
is 5.
Okay, how about this? If I have 5 and I want to change it into base 5, how do I do it? You say, how many places in base 5 does 5 take? Well, I don't know. So you start off with the 1s, the 5s, the next one is 25, not 10. It's way too big. 5 goes into 5 how many times?
1.
With a remainder of?
0.
So when I write 5 in base 5, it's written 10. Oh, okay. How about 4 base 7 plus 6 base 7? Okay. Now 4 has a value of 4, and 6 has a value of 6, and 4 plus 6 is still 10. It has a value of 10, not numerically 10, but a value of 10. But we're in base 7. So how do I write 10 in base 7? Well, how many 7s are in 10? 1 with a remainder of 3.
So, okay.
Okay, say that one more time.
If I have to, this is the long way. I don't want to do it the long way every time. I want to change 10 into base 7. How many place values in base 7? Well, that's 1, 7, and 49. Too big. 7 goes into 10 with a remainder of 3. And please don't read that as 13. It is 1, 3, base 7.
So are we gonna have any other bases on there?
No.
Okay.
That is one question that always comes up, and my answer is you cannot do it until you convert one or the other into its other base, or convert both of them into base 10.
That's what I'm asking, with the, when we have one, we have to convert?
No.
Oh.
No, I won't do that to you. That would take too long.
What if the answer would have been like, 6 base 5 plus 3 base 5?
6 base 5. Can I yell at you for a second?
Plus,
Stop right there. Can there be a 6 base 5?
No, higher
No.
than 5.
Because the only symbols in base 5 are 4, 3, 2, 1, 0. There is no symbol for 6. So that's an illegal.
okay, what about 4 base 5 plus 3 base 5?
What's 4 plus 3?
7.
5 goes into 7. How many times? With a remainder of?
So there's no symbol for 7 either. And that's what I'm trying to figure out. How
There's
do we know-
only 0, 1, 2, 3, 4.
Okay.
You
So
can't
there's
write anything else except for
nothing
0, 1, 2, 3.
higher
No.
than the base.
Gosh, no.
So what I'm doing is I'm adding numerically and dividing by the base.
You're adding in our system and then converting it into
And
their
dividing
system
by the
and
base.
dividing by the base, yeah.
Okay.
Yeah.
I might-
You want to shortcut it?
Yeah, that I can understand.
Yeah.
Sherman like.
So, the one you just made up, the one you just did, you just basically added 4 plus 3 and then you added 5 more.
Mm-mm. I added the 4 plus 3. I took the answer and I converted it into base 5. 4 plus 3 is 7. How many place values in 5 does it take? Well, 2. 5 goes into 7 once with a remainder of 2. I did not add anything to it. I just converted it. How about 3 base 12 plus um, 8 base 12. 3 base 12 plus 8 base 12.
11 base 12?
11 base 12?
One,
One.
12.
It's 11 base 12.
One.
Because there's a symbol in base 12 for 11.
A, B.
Oh.
You knew what we meant. Trying to be funny.
Yeah.
Yeah, but if you write 1, 1 base 12, that actually equals 13.
Okay, why do you have B12 and then it for?
Oh, I use B, the book uses
E.
E
Oh.
for 11. They use T and E for 10 and 11. I'd rather use A and
B.
Which one you say he used?
No.
He used B.
So we can't use letters for the base numbers, right?
Please don't, because you can't.
Which, because the book uses E, but he uses the letter B.
All right, 9 base 16 plus 5 base 16.
D16.
D,
D.
because 9 plus 5 is 14, and 14 in base 16 is
D.
D. Oh, don't forget the 16.
Oh, okay. Right?
Yeah, because you take off points for that.
Heck yeah.
I'm glad you said it. You got
Yeah, I
excited
remember
when you said it.
What? Is it E?
It's D.
A, 14.
E.
A, B, C, D.
E?
D.
It's D4.
D, 14. 10, 11, 12, 13.
Oh,
it's E.
It's E.
Well, with the remainder.
A, B, C, D, E, F, 10. I tell you, just write this on your paper and be done with it. There. So 9 plus 5 is 14, and 14 is the symbol for,
E.
the symbol is E. All right, how about this then? 4, 3, base 7, plus 2, 6, base 7. Now we're doing 2-digit numbers. Now notice, I lined them up so that I can add them. If you put them side by side, people start reading this as 43 and 26. They add those two numbers together, and what happens is you get the wrong answer. Even if you take that answer and convert it back into base 7, it doesn't work. So what you have to do
So you
with
got
this,
9.
you have to add the ones placed together, and then you have to add the, there's no 10s here, the 7s place. There are no 10s here. Don't ever work in base 10. We're not working in base 10, we're working in base, well, in this case, 7. So when you add the ones together, you go 3 plus 6 is 2 big. It's a big symbol because it's bigger than 7. So 7 goes into 9 how many times? 1 time. Let me change colors here. 1 time. Now that 1 7 has to go into the 7's place. That's why you put that 1 there, because it represents 1 7 that you can't use in the first column. So 3 plus 6 is 9. 7 goes into it once with a remainder of
2.
and the remainder just goes down here.
What?
Well, you don't trust
I
me?
had 69.
Oh, okay. All right, hold on. You all don't know how to add. I forgot. Wait a minute.
No, we're not.
No, no.
Okay.
73 plus 68. Regular old base 10 numbers. 3 plus 8 is
11.
11. What do you do?
Carry the 1.
Why?
Because you can't put it
That's
there.
to another place value.
I need to move it to the next place value because 11 is too big to put here. So I say 10 goes into 11 once with a remainder of 1. 7 plus 1 is? 8 plus 6 is?
14.
I can't write 14 here in one position, so I have to say, oh, that must go into the hundreds place and leave behind
Yeah,
4.
we understand that.
Great, but this is base 10. You're so used to it, you just do shortcuts all the time. You can't do shortcuts over here because you're not used to base 7.
So can you do that one again?
Which one? The base 10 or the base 7?
One by one.
Yeah. 3 plus 6 is?
9.
9 is too big. I can't, there's no symbol for 9 that can go into one position down here.
1 7.
So I say 7 goes into 9
1
one time. This 1 over here represents 1 7 because I moved it into the next place value. Then what's left over after I move the 7 is 2. He must be how many 1s are left behind.
And why you can't put the 9 down there?
Because there's no symbol for 9 in base 7. Base 7 is 0, 1, 2, 3, 4, 5, 6.
So you have to separate the column.
I have to separate away anything
Yeah,
that goes
each
above and
column.
beyond the base.
So you have to do each column.
Yes.
Gotta go to the next.
So you start at the 1 to do it,
Yeah.
and you go to.
Yeah. Just like you would if you had 2 huge numbers you had to add together.
So because
Now, 1 plus 4 plus 2,
7.
that's too big. I can't write 7 here. So 7 goes into 7
1 time.
one time. He moves over a place value. That becomes basically 7 squared. And then what's left over? Nothing, so I put a 0. So it's 1, 0, 2, base 7.
I'm lost.
You'll get used to it.
Hey, so
Every semester, I get the argument in the beginning, and then people go, oh, is that it?
Where does the 2 come from?
Because when you add 3 and 6 together, you have a value of 9 to deal with. Putting this 1 over here represents 7. What's left over? I have to deal with all
So
of
the
it.
remainder go at the bottom.
Yes. I have to account for 9. That's 1 7 plus 2 is 9. Yeah.
So we gotta know the bases, like.
Oh, you have to know the bases inside out, upside down. Yeah.
Can you do another double digit?
Oh, I can do many. Let's do triple digits.
Oh, come on.
2,
Stay with double.
3,
Yeah, wait,
5, a 6 plus 1, 5, 5,
I ain't got no more
a 6.
legs. I still don't even know where you got the 10 from.
Well, pay attention to this one and see where the 2 came from.
here and I say.
When I add these together, I start with the ones column. 5 plus 5 is 10. Too big. So, I take my base, which is 6, I divide it into 10, and I get 1. So I carry a 1. That represents 1 6. What's left over? 4. So I put 4 down here. There's 4 1s left over. Then you go 1 plus 3 plus 5. 9. Too big. 6 goes into 9. 1 time with a remainder of 3. 1 plus 2 plus 1. Do I have to do anything to it? No, just write it down. 4. 4, 3, 4, base 6.
Okay, that's not, wait. That don't look like that first one.
It is. It's identical.
Well, I don't.
So if it's less than the base.
Yeah, you don't worry about it. You have a symbol for it. But if it goes base or bigger, you have no symbols for it.
Oh, okay.
Which one?
Right here.
This one?
Uh-huh.
Or that one?
The other one.
This one.
Uh-huh.
5 plus 5 is?
10.
But that's too big, so I divide 6 into it. 6 goes into it
Yeah.
once with a remainder of
Um,
4. Let's go back to our numbers for a second. 7, 7, 7 plus 5, 6, 7. 777 plus 567. No shortcuts. No, oh, let's just do this because someone taught me how to do this. 7 plus 7 is, there's no symbol for 14 in base 10. So I say 10 goes into 14 once with a remainder of 4. No one ever wonders where that 4 came from. 1 plus 7 plus 6. 14. Too big. 10 goes into 14 once with a remainder of 4. That's 1, 10, and 4 ones, better known as 14. 1 plus 7 plus 5. 13. There's no 1 symbol for 13, so 10 goes into 13 once with a remainder of 3. That's really the pattern that's going on all the time.
So
I could care less what base we're in.
you just kind of ignore the base a little bit in the end.
I don't ignore any bases. You can't.
What's really getting me is like that very first one you did when you moved it over and then you put the 0 back in. Yeah, what's the 0 for?
0 left over. Because 1 plus 4 plus 2 was 7. 7 goes into 7
One time.
with a remainder of.
Okay.
If I put the 1 here, then this is 1, 7 plus 2, which is only.
How is 0 a remainder when it's nothing? So it's pretty much.
You're going to make me write something, aren't you? 99 plus 11. 9 plus 1.
10.
Do I put a 1 here?
No,
Why?
because it's not 11, it's 10.
Right. So therefore, what's left over?
0.
0, because 10 goes into 10 once with a remainder of 0. 1 plus 9 plus 1 was 11. 10 goes into 11 once with a remainder of 1. You have to have a placeholder if you don't have any values in that place. It's a placeholder, yeah. Alright, let's try another one. I knew this would turn into an argument, but that's okay. How about 100110 plus 100011?
What happened to the base?
Ah, if it's a bunch of ones and zeros, trust me. Base 2. This one's extremely easy, but people screw it up because all you can write are ones and zeros. If you're tempted to write the digit 2, don't, because there is no 2 in base 2. 0 plus 1, 1. 1 plus 1 is 2. Too big. 2 goes into 2. That goes over to the next column with a remainder of
0.
That means there are 0, 2's left over. 1 plus 1 plus 0 is 2 again, but it's too big. So 2 goes into 2 with a remainder of 0. 1 plus 0 plus 0. 0 plus 0. 1 plus 1. So how do I write it? I can't write 2 0. 1 0. So there's your answer.
Alright, so why did you, I got why you did it for 2, but you got like 7 base and like 6 base. Why did you subtract 10 from it? I mean,
I didn't.
huh?
I didn't.
No,
Not
I'm
here.
saying you was like, it doesn't.
5 plus 5 is 10. 7 goes into 10 once with a remainder of 3. 1 7 plus 3 is 10.
No, 10.
Why are you subtracting?
I know what
1
I'm saying.
7.
Alright, you subtract.
I didn't subtract.
You did that one.
0 plus 1 is 1. 1 plus 1 is 2. 2 is too big. 2 goes into 2 once with a remainder of 0.
Okay, now the base over here is 7. So why did you take it to 7?
This is 7.
Yeah, so you
These
was
aren't
like,
7. This is
You took 7.
3 plus 6 is
9.
7 goes into 9 with a remainder of 2. I'm subtracting, yes. I subtracted over there too. 2 divided by 2 is 1.
Okay.
Alright, and then subtract the 2 and you're left with? Okay. You're lucky I didn't have to learn how to count by these numbers. How about this one? 4C3 base 16 plus 3, 8, 9 base 16.
So can we can't, can we?
What?
Okay.
That wouldn't add up. I was gonna suggest, like, could we just, like, replace the C with 12, but then that would be too many, right?
Well, it is 12. It has a value of 12, but don't write it as 1, 2. Because if you write it as 4, 1, 2, 3, you've actually taken up 4 place values when it's really only 3. All right, 9 plus 3. What do I do?
Right, C.
You write a C. It's base 16. There is a symbol for 12 because it's smaller than 16. A, B, C, 10, 11, 12. So C goes here. C represents 12. So here, if you want to cross it off and replace it with the value, you can. That's 12. 12 plus 8 is? I can't write anything because 20 is bigger than 16. 16 goes into 20 one time with a remainder of 4.
Yes.
1 plus 4 plus 3,
8.
and I just write it because it's smaller than 16. So the answer is 8, 4C, base 16.
Okay.
It's like pulling teeth. Oh, I should have become a dentist. Okay, how about one last one? 4, 3, B, 7, base 12, plus 3A, 2, 4, base 12. Nice long string that we can do one at a time. Half of this is one at a time. The other half is just keeping in your mind that you're not in base 10 and you have to be careful of what symbols you're writing down. 7 plus 4 is an 11.
B.
It's either E or it's B. I'd rather B personally. A is 10, B is 11. The book, of course, remember uses T and E. B represents 11. 11 plus 2 is? 13 is too big because we're in base 12. So 12 goes into 13. One time, he moves over one place value. Left over? 1.
So why you ain't just put
Wait,
the letter down like you
wait.
did earlier?
I swear to
I
God.
got
That's
a-
not
Because
11.
13 bigger than 12. I got a question.
13. It's 13. This is 13, which is 112 plus 1, which is 13. You'll get it eventually. I just have to fight it in there.
8, 2, 1.
Oh, shh, quiet. 1 plus 3 is 4. 4 plus A is 14. I cannot use the symbol in base 16 here because it's bigger than 12. So 14 divided by 12 goes in once with a remainder of 2. 1 plus 4 plus 3.
8.
8.
Base 12. I forgot my base 12.
Yeah, don't forget your base 12.
So, the 7 and 4. The answer so you wouldn't put down.
The golden rule is this. If the number is base smaller than the base, write a single digit. Your answer is going to be a single value, single symbol. If your number is your answer, you add them up and it comes out to be your base or bigger, you got to do division.
It's a letter.
No, you got to do division.
But it's a letter.
No, you got to do division.
I know.
How is it a letter if I'm doing division? 7 plus 4 is 11. It's a symbol because it's smaller than 12. But B plus 2 is 13. That's bigger than the base, so I have to do division. 12 goes into 13 once with a remainder of 1. Ah.
You forgot to add, no, you forgot to add the one that you took from the other side.
Here? There wasn't a 1.
Right there.
I just did the B over 2.
Oh, okay.
I didn't go to the
doing
next
A.
one. No, I didn't do that.
You was getting ready to change something too fast.
No.
Not change.
Try this one. 3, 2, 4, base 5, plus 1, 3, 2, base 5. If you're having trouble with this, it's because you haven't added two numbers together in a long time. You've been using a calculator, or You learned how to do it, but then you went with the algorithm and just assumed that you put a 1 up there because it represented 10.
That's what my problem is.
Yeah, you're thinking 10 in your head.
Because where that B was,
Yeah, I know.
I was putting 11 and
I know.
I took the 1.
But you can't. You can't write 11. It
You
doesn't
have
make
to use
sense.
the letter.
Yeah,
B.
because it's smaller than the base. It's one symbol. You should be done by now.
Is it 10, 11?
No, don't be saying 10.
1, 0, 1.
I don't know. 4 plus 6?
Yeah, I second that.
4 plus 6. 4 plus 2? 6. 5 goes into 6? 1's with a remainder of 1. 1 plus 2 plus 3?
6.
So you get the 1, 1 again. 1 plus 3 plus 1? 5. But 5 goes into 5. 1's with a remainder of 0. 1, 0, 1, 1. That's addition. Subtraction. Subtraction's easy.
I have one more question.
What? That's man.
I'm gonna leave you alone.
You're gonna leave you alone.
I'm sure.
Yeah. So it's addition when the base is lower than 10, right?
No. It's addition because I put a plus sign there.
So how do you know when to do addition and division?
If you add them together and the number becomes your base or higher, you're going to do division by the base. But if it's your base or smaller than your base, you're just going to add them and put the answer down. All right, subtraction. Subtraction. Subtraction is actually the one that people don't screw up, which is kind of funny if you think about it. They screw up the addition because they get so confounded with that base 10 numbers in your head. Subtraction takes it away because you don't usually have to worry. Like for instance, if I do 5 base 7 minus 2 base 7, what's the answer? 3. The thing with subtraction is it always makes the numbers smaller. The only difficulty comes when the numbers are switched around and you have like 2 minus 5. Then you have to do some weird stuff. So let's talk about our kind of numbers. 4, 2, 3 minus 423 minus 257.
No base?
No calculator. It's base 10 because I read it as 423 and 257. Now, when you get to the ones and you say, oh, 3 minus 7,
6.
you can't do it. So what do? No, don't be doing shortcuts. You have to do everything long ways.
13.
No, don't say 13 either because then that won't carry over. Shh. I need a method that works here and in other bases. If you just use your algorithm and you go for the answer and just wing it, you're not thinking about every single little step that's going on here. So let's just slow down a second. Can I do 3 minus 7? No. So what do? Borrow. Now when you borrow, you're taking a 1 away from this 2 and leaving behind 1. What am I borrowing? 10. That's the important part. When you put a little 1 here and you write it as 13, that's not going to work for us. So I need to cross this off and say 10 plus 3 is 13. 13 minus 7 is 6. 1 minus 5. Can't do it. So I'm going to have to go to the 4 and borrow 1 from 4. 1, in this case 10 from 4. Give it to the 1 that makes this 11. 11 minus 5 is 6. And then finally 3 minus 2 is 1. So when you're borrowing, you always borrow your base. In this case, it's base 10. You're always borrowing 10 and giving it to the next place. Doing opposite of what addition did was push a 10, or push a 7, or push a 6, depending on what base we're in. So what about 423 base 8 minus 257 base 8? Question number 1. Are these the same values?
No.
No. One's in base 10 and the other one is in base 8. Just because they have the same digits means absolutely nothing. Are the answers going to be the same?
No.
Heck no.
So what? I'm going to borrow 8 instead of 10.
Yeah. So, you can't do the 3 minus 7, so you're going to borrow from the 2. The 2 becomes a 1. But what I'm borrowing is not 10 anymore, it's just 8. 8 plus 3 is 11. I had to think about that for a second. And then this is a normal 11 minus a normal 7, which has a normal answer of 4. Now, 1 minus 5. Yeah, can't do it.
So
Borrow from the 4, he
8.
becomes 3. The 1 gets attached to a
9.
8, it becomes 9. 9 minus 5 is
4.
4. 3 minus 2 is 1. Base 8.
Okay, now this is easier than what you going.
That's what I'm saying. Addition, for some reason, people have a heck of a time with. Subtraction is, they understand it. But addition is just the opposite of what we're doing here. Here we're pulling the base to the right. With addition, you push the base to the left. It's the same idea. All right. How about CE3 minus B F D. Just trying to mess you up. Base 16.
You just did.
With base 16, highly suggest A, B, C, 10, 11, 12, 13, 14, and 15. Just so you know what their values are as you're doing this calculation.
Just so I can know in ahead of time, are we gonna be doing multiplication?
Yes.
now?
It's coming. It's coming.
It's the same day.
Can I do 3 minus D? No, too big. So I go to the E, which is equal to, and I borrow 1 from 14, making it,
13.
do not write D. That's not worth it. Just write 13. Any number that you write on top is our numbers. Any number you write on top is our numbers. Any number you write in the answer is their numbers. So we're kind of doing a mixture of ours and theirs. Top is ours, bottom is theirs. All right, so now we borrow 1 from the E, give it to the 3, and it becomes 19. Why? Because I'm borrowing 16. Now, 19 minus D, which is 13, is 6.
6.
9 minus... I'm worried. 13 minus F, but F
14,
is
too big.
15, too big. So I have to borrow 1 from the C, making it 11. Because C is equal to
12.
12. So if I borrow 1 from the C, it becomes our 11. But the 13 now gets
29.
16 more, which makes it 29.
So it's E.
29 minus F, which is 15, is
4.
14. And 14 is
E.
E. Isn't that awesome?
No.
And 0.
Is that a B or A?
That's a B. 11 minus B, B is
Why the
11. So that becomes 0. So this is 16. Be careful. This number is our 11. This number is base 16, 11, but they have the same value. So the same value minus the same value is 0. So our answer is E6.
16.
E6.
Base 16.
Base 16. I thought you said. So subtraction for most people is actually the easier of the two, which I always found strange, but I guess I understand. Multiplication.
You want most subtraction.
Blah, 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 blah.
You want most subtraction.
You got it. Trust me on that. Most people get subtraction. It's this one I worry about.
Oh my God, then why wait?
I thought
I don't wanna wait.
addition.
Multiplication. This is the one I worry about.
Exactly.
But after a few tries, and if you do your homework like I asked you to do it, most people get this. The hardest one, of course, is division. Most people don't get that one. So, let's see here. Multiplication. If I take 38 and I multiply it by 5, this is regular base 10 multiplication. How do we do it? Well, you go 5 times 8. 40. Too big to put into one position. So 10 goes into 40 4 times with a remainder of 0. That's really what's going on. You're not writing 40. You're writing how many 10s and how many 1s. 3 times 5 is? And then what do I do with the 4? Does anybody know why? Really?
You added.
Yeah, but why?
You can't multiply.
I know, but why would you
put it
add
over
it?
there and
It
Put it in
goes
that
into
place
one.
See,
place.
this is the problem with education lately. No one knows why the heck anybody does anything. This is called the multiplicative algorithm. It's a way of multiplying numbers together. Is this the way it's always been done? More than likely not. There is another method that was used in the Middle Ages, which is actually kind of cool. I'll show it to you in a second. But this is an algorithm, and the reason it works is because of one property in math. Anybody remember the distributive property? This is the distributive property. Look, you're going 5 times 8 and 5 times 3. That's the distributive property. So it has something to do with the distributive property. And what they did with the algorithm is they took all that mess and just made it a little bit easier to work with. Because it is messy if you do it distributive property-wise. All right, so 5 times 3 is? 15 plus 4 is? 19. And you would write 1, 10, and 9 ones. So you get 190. Woohoo. So what if I change it into 3, 8 base 12 times 5 base 12? Let's just jump right into the higher bases. These are not the same values, so therefore the answer is totally going to be different. So don't expect the same thing. The biggest mistake I have seen, someone taking 38, multiplying by 5, and taking that answer and converting it into base 12. That will not get you to the right answer, because that is not
Same.
38. This is 3, 8 base 12. It's totally different. But we do the multiplication the same way. 5 times 8 is 40. Too big for base 12, so 12 goes into 40 how many times? 3 times with a remainder of 4. It's 36. 40 minus 36 is 4. Then you go 5 times 3 is?
15.
Plus the 3 that's already there.
18.
Too big. 12 goes into 18. 1 time with a remainder of? 6. Base 12.
Where do you get that from?
5 times 8. Yeah, where did that 4 come from? Oh, I know. This is 40, right? 12 goes into 40 3 times. And when you do that, it has a remainder of 4. It's the steps. What if I do 27 times 13? Base 10. Our numbers is 27 and 13. So 3 times 7. 21. That's 2 10s and 1 1. 3 times 2. 6 plus 2. 8. I can write that. 1 times 7. Now where do I put it? Why do I put it under the 8? Because it goes in the tens place. Because this 1 represents 10, and 10 times 7 is 70. So it actually moves over, because we can write this as 70. So it moves the 7 over one place. 1 times 2, that goes over here. And then what do we do with the answers? Add them together. Again, it's because of the distributive property. It gets messy if you write it all out. Thank God for algorithms. 1 plus 0 is 1. 8 plus 7 is 15. That's 110 and 5 ones. 1 plus 2 is, so you got 351s. Yay! So what if I do 2, 7 base 8 times 1, 3 base 8? Different values, same multiplication.
7 and 3.
So 3 times 7? 8 goes into 21. 2 times with a remainder of 5. Because that would be, what is this? 21 minus 16. 3 times 2?
6.
Plus the 2?
8.
Too big. 8 goes into 8. 1 time with a remainder of 0. It's really important to get that 0 in there. Now you just have 1 times 7 and 1 times 2, which is 7 and 2. So the 7 goes here, the 2 goes there. Then you have to add. 5 plus, no, nothing is 5. 0 plus 7 is, well, that's easy, 7. 1 plus 2 is 3.
375.
375. 375. Let's see if I can come up with one. 4, 2 base 12 times 2, 3 base 12. I think this will work.
2 times.
Well, we'll see if it works. I'm not sure if it does. I mean, it'll work, but not for what I'm looking for, I don't think. 3 times 2.
6.
Yeah, I could write that. 6. 3 times 4.
12.
What do I write?
0,
1 and a 0. Because 12 goes into 12 once with a remainder of 0. Nah, this isn't going to do what I wanted
Oh,
to do.
that's gonna come out.
That's all right. 2 times 2. That goes here. 2 times 4.
And
That goes there. No, it's not going to do it. 8, 4, 6. That's boring.
That's
946.
Oh, be quiet.
Base 12.
I'm looking for something specific. It's not working for me.
That's fine.
5, 3, base 12 times.
You trying to trick us up? That's what
Well,
Now you trying to make a bigger digit.
I'm trying. No. I'm trying to get it so it has one specific thing when we're adding them together. I might actually have to look at my notes. This is horrible. 3 times 5. 5 times 3. I'm sorry. Too big. 12 goes into 15.
one,
With a remainder of 3. 5 times 5
25,
plus 1.
26,
12 goes into 26.
2,
With a remainder of
4,
4. It's 24 minus 26. 2. Or 26 minus 24. 3 times 3.
9,
What do I write? 9. 3 times 5.
15,
15 plus 1. 16. So that would be
4,
1 and 4. Because 12 goes into 16 once with a remainder of 4. Ah, this one's working. Good. There's a reason I like this one. 3 plus 0.
3,
3. 2 plus 9.
and
What do I write?
B,
Thank you. You do not put a 1 up and a 1 down. You are adding in base 12. So when you go 2 plus 9 is 11. That's smaller than 12, so there has to be a symbol for it, and it must be
16, B, 3, base 12.
2 plus 4, of course, is 6. And don't call it 16.
1,
6,
6,
B,
B,
3,
3,
base 12. Yay! That's multiplication. Not that hard. So let's get to the one that I'm curious about. We just have enough time for
See,
it.
you curious about everything. Every section.
Division. The problem with division is this. When you learn division, you had to know something first. What did you have to know?
To divide.
You had to know how your multiplication facts. You had to know that 7 times 6 is 42 and all of those. The problem with division is we don't know our multiplication facts in every single base. I don't know what the multiplication facts are in base 5, base 4, base 12, base 16, and I'm not about to go and learn them. So the trick here is you have to create your own in a way. For instance, if you do 23 and you divide it into 9, 8, 0, 1, 2 without a calculator, the problem is this. If you look at it, you don't know your multiplication facts of 23. And I don't know how many times it goes into 98. So you go, well, it's bigger than 1. 2 times this is 46. 3 times this is 69. 4 times this. And you'd have to go through and find out which one works. I think it's 5. 4?
No, it's 4.
It's 4? So you go off to the side and you'd have this multiplication thing written out. If you had to do this by hand, no calculators, you cheaters. So this is what, 12,
92.
92. So you'd put the 4 up here, this would be 92. You subtract and you get 60. Well, how many times does 23 go into 60? Well, it's not 1, it's 2, right? So you put 2 here, this would be 46. That would leave you with 41. Oh, gee. Well, I know it's not 2, because 2 was 46, so it must be 1, and then you get 23, subtract, and what do we get? Borrow 8, 18, and then we drop the 2. Oh, good God. What times 23 goes into 182?
9,
How'd you find out?
6.
Did you use your calculator?
6.
No, I didn't.
Well, let's go back to 6
It's
and
14, not 4.
14.
For
Yeah,
60
that's not
minus
right.
46.
That
Oh.
one should be a 6.
I was about to say, I know I ain't stupid.
I'm
I'm
stupid,
just
don't
going
mind
down
me.
here.
1. So this is 141. Oh, good God, that's horrible.
Yeah, and they go in 6 times.
Yeah.
And that's 128.
Okay. But either way, you'd have to find out the that it went in 6 times without a calculator. How many use a calculator? Let's be honest. Yeah.
All you got to do is.
And that's the danger. But here's the thing. Calculators don't work in base 8 or base 12. You have to come up with your own facts. So guess what? Calculator's not going to help you. So Let's do a base one. A simple one.
It don't matter. Just find blue point.
4 base 5 into 1, 2, 3, 4 base 5. Making it up. Let's see what happens. Now be careful. This is not 4 goes into 12. This is not 12 because we're not in base 10. So you have to kind of come over here and do your multiplication facts. 4 base 5 in this case, base 5. So you start off with 4 times 1. Highly suggest you put the numbers on top of one another because once you start putting them next to each other, left to right, you start reading things like 12 and 13 and 14, and nothing in this world is 12 or 13 or 14. 1 times 4. 4, I hope so. So then 4 times 2. Well, 2 times 4 is? 8. Too big because we're in base 5, so that's 1, 3. 1, 3 in base 5 is equal to 8. And then 4 times 3 is 12, but that's too big. 5 goes into 12. 2 times with a remainder of 2. 4 times 4 is 16.
3.
5 goes into 16 3 times with a remainder of 1. Do I have to do 4? Do I write this?
No,
Why?
because it's bigger than base 5.
5 or bigger.
So
There is no
0?
symbol for that one right there. In base 5, there is no symbol for 5. We can't use it. So this one is as far as we need to go.
So we write 0?
Don't write anything.
So we don't do 4 times 0?
There's no point in going to 4 times anything. You only have to go to the largest symbol in your thing. When you do multiplication facts, technically you're only supposed to go to 9 in base 10. They make you go to 10, but you're only supposed to go to 9. Okay, so when I say 4 goes into 1, 2, which one of these am I going to use?
4.
The 1.
Okay.
Because 1 times 4 is 4. 2 times 4 is 1, 3, which is too big. So I'm going to use the 1, put a 1 up here, put the 4 down here, and now I have a danger.
Subtract.
You subtract them. And you get?
It's too big.
It's too big. This is not 12 minus 4. This is 1, 2, base 5 minus 4, base 5. When I do the subtraction, I have to borrow from the 1 to make it a 0. The 2 becomes 7. 7 minus 4 is 3. That is where most people make their mistake. They start calling it 12 and they get 8, and you can't write 8 in base 5. So, what do I do next?
Bring down the 3?
Bring down the 3. 4 goes into 3, 3.
4 times.
4 times. 4 times 4 is
31.
3, 1. Not 31, 3, 1. When you subtract here, it's easy. 3 minus 1 is 2, and 3 minus 3 is 0. Bring down the 4. Which one do I use? 3. So I put a 3 up here. This becomes 2, 2. And I subtract, and I get 2. Because 4 minus 2 is 2, and 2 minus 2 is 0. So my answer is 1, 4, 3, remainder 2.
Base 5.
Base 5. I don't like remainders. Remainders have a use in math. It's called modular math, and you've never learned it. So technically the answer is 143
Base 5.
and 2/5 base 5.
But either way, if you use two something, we write.
Oh, I'm sorry, 2 fours.
Why? Why is it 2 4s?
As you're dividing by 4.
Okay.
You're dividing by 4. Which is actually 143 and a half base 5. But this is what I'll take on the test.
Good.
I don't like the remainder thing because nobody knows what to do with it. And it gets you in trouble later. Ugh. So, is that easy?
So far.
It can be, but the problem is if you forget to do your multiplication tables, or if you do your multiplication tables wrong, your answer over here is going to get screwed up. And the other danger is right here. when you start reading things as 12 minus 4, you're in trouble right off the bat. You have to remember you're in a base and you have to treat it that way. The harder one is this. 1, 3, base 6 into
It's not.
1, 2, 3, 4, base 6. Just try it out. Why is this one harder?
Bigger base, more multiple.
Well, bigger base, we have one more multiplication. The other thing is it's a 2-digit number rather than
A one.
a 1. 2, for some reason, screws people up. So I'm going to go off to the side and do my little multiplication table in base 6. And I'm going to start off with 13 times 1 is, dang it, I already screwed up. I called it 13. You have to be really careful. That's 1, 3 times 1, which is 1, 3. You start calling it 13, the rest of them are gone. The next one is 1, 3 times 2. Do not go 2 times 13 is 26 and then convert it into base 6. You have to go 2 times 3 is 6, too big. That's 1 6 with 0 remainder. Just like with our multiplication. 2 times 1 is
2,
plus 1.
3.
So this is 3 0, base 6. 1 3 times 3. All right, 3 times 3.
9.
Too big. 1 6.
3.
3 1s. 3 times 1 is 3 plus 1 is
4.
4. So you get 4 3. 1 3 times 4. 4 times 3.
12.
6 goes into 12
2.
with a remainder of.
0.
Want me to do that again? 4 times 3 is 12. 6 goes into 12 twice with a remainder
Is it
of
100?
0. Don't say 100.
1 0.
1 0 0. 4 times 1 is 4 plus 2 is
6.
1 goes into it with a remainder of 0.
Zero.
You get 1 0 0.
We got
It is
one.
not 100. It's 36.
Okay.
That's 36.
15.
You don't believe me?
2 times.
1 3 times 5. 5 times 3 is
15.
too big. 6 goes into 15.
2.
2 times with a remainder of 3. 5 times 1 plus 2.
7.
Too big. And you get 1 1. 1 6, 1 remainder. Do I have to do this?
No.
No.
Why?
It's too big.
There is no such thing as 6 in base 6. I don't have to go any further than that.
Just 0.
I don't. Just leave it alone. Okay.
Now I say.
Now 1 3 goes into. Well, it doesn't go into 1 2, but it goes into 1 2 3.
3. 5 times.
5 times. So I put a 5 up here,
I'm subtracting.
5. And it becomes 1 1 3. Well, that's not bad. 3 minus 3.
0.
2 minus 1.
1.
And then the 1s are 0 also. And then drop 4. Hey, this is nice. 1 0 4.
4.
It's 4. Oh, this is too easy.
1 0 0.
1 0 0. And I subtract them and I get
4.
4 because 4 minus 0 is 4 and 0 minus 0 is 0 and 1 minus 1 is 0. So this is 5 4 remainder 4 base 6.